So here's a flowchart of the specific topics that we cover in this module. In the first two videos of the module, we covered basic concepts related to entity routing. So we talked about basic and transfer nodes and their properties and how they can be used to specify a destination node for the entities or to select an outbound link for the entities to take. So in terms of entity destination, we have two cases. The first case is when the entity does not have a destination node set. In this case, in the first video, we covered free space movement, where we do not have a network of link objects. In the case where we have a network of paths or connectors, we talked about the case where there is only a single outbound link. For the case where we have multiple outbound links out of our transfer node, we learned how we can use the properties of the transfer node to specify a specific link for the entities to take. And we also talked about selection weights very briefly in the first video of the module, while in the third video of the module, we looked at using selection weights for probabilistic and conditional routing, and also we learned how we can have compound probabilistic and conditional expressions for the selection weight property of our link objects. So the second general case that we talked about in the second video of the module was the case where the destination node of the entity is set. So in this case, we talked about how we can use a set node step or the entity destination type property to specify the destination node for our entities. So we talked about outbound link preference and outbound link rule and the different situations that can happen based on the choice of these two properties. In this video, which is the fourth video of the module, we're going to talk about dynamic routing using node lists. So dynamic routing is the case when we do not know in advance what the destination node of the entity is. However, we select the destination node dynamically based on the current state of the system. So consider a restaurant that has multiple cashiers. So when you enter this restaurant, you have multiple cashiers to choose from, and most likely you will choose the one that has the shortest line. So in this case, before you enter the restaurant, you do not know in advance which cashier you're going to choose, and your choice depends on the state of the system and the number of entities at each cashier when you enter the restaurant. So that's what we call dynamic routing, and that is what we're going to talk about in more detail in this video of the module. Finally, the fifth video of the module involves the case when the entities in our model visit a predetermined sequence of objects or nodes in the model. So as the entities move in the model, we know what the next destination node will be. So we're going to talk about sequence tables and how we can use sequences for this type of routing in the fifth video of the module. So in the previous video, we talked about how we can implement probabilistic routing, like what we see here, and also conditional routing and compound conditional and probabilistic routings using selection weights. In this video, we're going to make a little modification to our system. So now, instead of having one server with 3 units of capacity, we're going to consider 3 separate server objects for the document check station. So each of these servers will have its own queue, and what we would like to do here is dynamically choose which server the entity wants to go to. So let's go to Simio and see how we can implement this. So this is our model from the previous video. So what I need to do is remove this server that has 3 units of capacity. So when I run this model, what happens is entities wait in this queue, and whenever a unit of capacity becomes available, the first entity in the queue is moved to the processing station of the server and it's processed. So I'm maintaining first in, first out among all my entities here. Now the implication of having 3 parallel or separate server objects is that each will have its own queue, and the entity preferably wants to choose the one that is expected to be faster in terms of the waiting time in the queue. So we may not have first in or an absolute first in first out system anymore. So let me remove this server object and add 3 server objects. So these are the 3 document checks. So doc check 1, doc check 2, and doc check 3. So I'm just going to connect my source using paths to the 3 servers. And also note that since from each of these we have this probabilistic routing to the AIT and pre-check, we can either add 2 paths that go from the first station to AIT and the second one that goes from the first station to the pre-check, or alternatively we can use a transfer node that does this for us. So what I'm going to do is connect my servers to this transfer node that I just added to my model. And then I'm going to connect my transfer node to AIT and pre-check and have my probabilities on these 2 paths right here. So I have a probability of 0.9 to go to the advanced imaging technology for regular passengers, and I have a probability of 0.1 to go to the pre-check. So basically 10% of my passengers are eligible for pre-check. So now if I run the model, what we expect to see is that the 3 servers are selected randomly. So what happens is that we expect to see roughly about the same utilization for all 3 servers. So the arrivals will be randomly but equally divided between the 3 servers, if you will. So this is not what we want. What we want is that when an entity is about to, or when an entity arrives, the entity wants to choose a server that is expected to become available first. So we need something we call dynamic routing, and the way we do it in Simio is using node lists. So if I go to my model and definitions and then lists, here I can add a node list, and as you can see I have a drop down menu that lists my nodes, my input nodes in my model. So I'm going to have input at check 1, input at check 2, input at check 3. It looks like I have a typo here in my name for the server, so let me go back and fix the typo here. Check 2. So now I go back to my list and I have input at doc check 2. Oh, it's still not fixed. There we go. So doc check 1, 2, and 3. Alternatively, to make this node list, I could select my 3 input nodes that I would like to have in my node list, right click. So I have selected all 3 in the multi-selection mode by holding down the control key, and then I can add to node list and then create a new node list. And you can give it a name, say OK. So now when I go to definitions in my list, I see the second node list that I just created by using the shortcut method. So again, the 2 node lists that I have here are exactly the same. So I'm just going to remove one of them. So now when I click on the output node of the source, and in the properties you will see that we have an entity destination type property that is set to continue, which is what we have used so far in the previous models. And basically what it says is just continue using the selection weights. Now, if I click on this little arrow, you will see that we have other options. We're going to talk about sequences in detail in the next video. We have the select from list. We can also use specific or custom routing groups. So what I'm going to do is select from list, and Simio gives me this error that says, well, you haven't specified which list you would like to use. So I'm going to select the node list, which is my node list 1. That consists of these 3 input nodes. And I also have 3 properties for how I would like to choose from my list. So I have the selection goal, selection condition, block destination rule. We're going to focus on the selection goal, which is defaulted to preferred order. So the preferred order says, well, I have listed my nodes in this order, so I'm just going to check the first one. If it's available, or if it has capacity, I will send my entity there. And then if not, I will send it to the second one. If the second one has no remaining capacity, then I will send it to the third one. So when I run this model, what we see is that all of the entities are routed to the first station, and none of them is routed to the other 2. And that's because we have this station listed in the first row of our list. But the reason that all of them go here is that we essentially have infinite capacity in our first server, because the input buffer size is set to infinity. So the capacity of my input buffer is infinity, so this server always has capacity. So when I'm selecting based on the preferred order, I'm always sending my entities to the first station. So now, in order to see how this preferred order selection goal works, I'm going to select all my 3 servers and then set the buffer capacities, the input buffer capacities, to 0. So now what happens, and I'm going to run in the step mode, when my first entity arrives, it checks the first server, and since it has capacity available, it goes to the first server. When the second entity arrives, the first server has no remaining capacity because the processing station is already busy and the input buffer capacity is 0. So it will go to the second station, as you can see. The third entity will be routed to the third station because the capacity of, there is no remaining capacity in the second one, and so on. So when we run this model right now, what we see is the output buffer of the source is used as the queue, and then whenever one of these servers becomes available, we send the entity, the first entity in the line, to the first server that becomes available. Also note that this process works if I increase the buffer capacity. So let's say I have a buffer capacity of 4. So now what I expect to see is that first, let me slow down the model a little bit. So what I expect to see is that Simio will first fill the first capacity of this first server, and once the first server has no remaining capacity, that means in the input buffer or its processing station, it starts filling up the second server. And then when the second server is filled up, it sends the entities to the third server. So let's run the model and see if it's how that happens in Simio. So as you can see, the entities are first sent to the first server. When the first server has 4 entities in the queue, they're sent to the second server. And in fact, if you run long enough, and you will see that this, and we just saw that. So when the second server becomes filled up, the entities are routed to the third server. And of course, we can go back to our list and change the sequence of the nodes in our list however we want. So that's the order preferred selection goal. And let me go ahead and talk about a couple of other options that we have here. So if I open this drop-down menu, you will see that we have smallest distance, largest distance, cyclic, random, and so on. What I would like to talk about now is the smallest value as a selection goal. And the selection expression is defaulted to candidate.node dot associated station overload. So what it tells me is that I'm going to select from my candidate nodes the one that has the smallest value of associated station overload. So the station that has the minimum overload. So let's see how Simio defines this overload by going to Simio's help and then search for associated station overload. In fact, when you do that, I'm going to go to functions, states, and events for node objects. Let me scroll down here a little bit. As you can see, we have a description for what this associated station overload expression is. So basically what it does, it returns the difference between the load and capacity values. So it's a positive difference indicating what Simio calls the overload of this station. So the load of this station is defined as the sum of the current entities en route to the node intending to enter the station, plus the current entities already arrived to the node but still waiting to enter the station, plus the current entities occupying the station. So that's how Simio defines the load, and then the overload will simply be the load minus the current capacity. So let me close the help and go back to the model and run this model. Remember, we have input buffer capacities at 4. So what the preferred order selection goal would do for us, as we just saw, is that it only sends entities to the second node in my list when the first one has reached its capacity. It has no remaining capacity in the station, in the processing station, and in its input buffer. But what the smallest value of associated station overload does for us is that it sends the entities to the station that has the fewest entities in its processing station, input buffer, and en route to the station. So now when we run, we will see that we do not wait until the first server is filled to send entities to the second station. So the last dynamic routing option that we're going to look at is an option that allows us to choose the server that has the fewest entities in the buffer. So this time we're going to select the destination node for our entities based on exclusively the input buffer and the number of entities that are waiting in that queue. So in order to do this, what we need is change our expression from associated station overload to associated station dot contents. So now the associated station is our input buffers, input nodes, and we're specifically looking at its contents, which returns the number of entities that are waiting in the input buffer. So when we have candidate node associated station dot contents, we're looking at all of our candidate nodes and we compare the number of entities in the queue, and then we pick the server that has the minimum number in queue. So now when I run this model, you will see that I'm exclusively choosing based on the number in queue. So it is possible that when I have multiple entities en route to the station, since they haven't gotten to the input buffer yet, I still send the next entity to the same station. However, this process works even if I have infinite input buffer capacity. So infinity for all. So now when I run, you will see that while the other two methods that we covered do not work for infinite buffer capacities because they result in an infinite total capacity for the servers, this approach, however, works even if we have infinite buffer capacities. So far we've talked about dynamically selecting the entity's destination node based on a preferred order of candidate destination nodes, the overload of the candidate stations, or the contents of the candidate destination nodes. So to wrap up this video, let's have a look at the remaining options that we have for the selection goal property. Of course, the smallest distance and largest distance and random are self-explanatory. Largest value is similar to smallest value. Let's have a look at cyclic. So as you can tell from the name, we have this list of candidate nodes. I have input at doccheck1, input at doccheck2, and input at doccheck3. So the cyclic just goes in a cyclic manner through this list and selects the destination node. So the first entity is going to go to doccheck1, the second entity will go to doccheck2, third entity will go to doccheck3, and then we're going to start over from the beginning of our list. So the fourth entity will go to doccheck1, and so on. So now when I run this model, you will see that my first entity will go to doccheck1, my second entity will go to doccheck2, my third entity will go to doccheck3. So we're not worried about the contents or the overload of the sessions anymore. We just go through our list in a cyclic manner. Also, we can have an optional selection condition that, based on the description, is an optional condition evaluated for each candidate destination that must be true for the destination node to be selected. We also didn't talk about block destination rules, so we have a couple of options there. These are the topics that will be covered in a related video module.